Hello guys, welcome back to a new video. In this video we will finish some of the questions that are left in chapter review. Question 17, it says the figure shows unit conversion on the labels of some grocery store items. Check the accuracy of these conversions. Are the manufacturers using significant figures correctly? I'll just explain A. 0.9 ounce is equal to 25.51 grams, okay? And they have rounded this number to 26 grams, okay? But here, okay, it says that 0.9, it indicates that 0.9 ounce is exactly equal to 26 grams, okay? The number should have been written like this, to 26.0 grams, okay? So that this 0 will tell you that this number is not exactly 26. It has been rounded up, okay? So no, the significant figures are not consistent between the values of each conversion. The value of speed of light is known to be 2 point something times 10 to the power of 8, 10 to the power of 8 meter per second. A, write this number with three significant figures. We can write it like this, 2.99 times 10 to the power of 8 meter per second. This is one way. Now, with five significant figures, you can write 2.99 and 7 and 9, okay? This is 1, 2, 3, 4, yeah, you have 9 significant figures. Here with 7 significant figures, you have 1, 2, 3, 4, 5, 6, 7, so you can write 2.997924 times 10 to the power of 8 meter per second. This is basically how you can write this number in different significant figures. Now, how many significant figures are there in the following statements? So you have 78.9 plus or minus 0.2. So you have 1, 2, 3. Doesn't matter whether you add or subtract 0.2 from this number. You still get 3 significant figures, okay? So you have 3 significant figures. 1, 2, 3. 3 significant figures. This one, we mentioned that you don't count powers of 10, so you only have 4 significant figures. Here, you don't count powers of 10, so you only have 3 significant figures. Here, you don't count these zeros because they are in front of the decimal, the left side of the decimal, and they don't have numbers, or they don't fall between 2 non-zero digits, so you only have 2 significant figures. 2 significant figures. Carry out the following arithmetic operation. Just add these numbers together. This one with this one, with this one, and this one. This one, it says find the coefficient of 3.2. So just divide 3.2 by 3.563 meter per second, of course. Then you'll get something in meter per second, okay? Just divide it and that's it. Find the product of, just multiply 4.67 times pi, which is equal to 3.14, and you'll get a result. Find the difference, so you'll subtract 27.54 minus 3.8. Just subtract them and you'll get a result. Question 21. You have a fisherman catches 2 sturgeons. It's a fish. The smaller of the 2 has a length of 93.486 to its decimal place and 4 significant figures, and the larger has a measured length of 135.3 centimeters. Basically, just it says what's the total length of the 2 fishes, okay? So if you have 2 fish, if you can draw a fish, and if you add the length of them, okay, I just ignore it, I cannot draw a fish. Now, if you basically have two fish, add the length of them together, and what will be the final length? You have 93.47 plus, with this one, 135.3. Add them and see what will be the final length. A farmer measures the distance around a rectangle field. The length of each side of the rectangle is found to be, so he has a rectangle field like this. Each length, so it's equal to 38.44 meter. And the length of each short side is found to be, so the short side is equal to 19.5 meters. What is the total distance around the field? So if you try to move from this point, so you go all this way and you come back here, okay? What will be the final distance? What will be the total distance? So guys, if you can see that these two are equal, so this one will be 19.52. These two are equal too, so this one will be also 38.44 meters. Okay, basically add the total distance, so you'll have total distance will be equal to, you can say 19.5 multiplied by 2 plus 38.44 multiplied by 2. Or you can just write it 90.5 plus 19.5 plus 38.45 plus 38.45. And you'll get the result in meters. Just add them and don't forget the unit. Suppose two quantities A and B have different dimensions. Which of the following arithmetic operations could be physically meaningful? So if I give an example, you remember that we had units, okay? Sometimes you have Newton dot meter, okay? Newton multiplied by meter, or you have meter per second, okay? So this one is what? This one is multiplication, and this one is division. So you only have these two arithmetic operations that have two dimensions. You cannot add them, okay, and you cannot subtract them. So only A, B, and C are correct, okay? Multiplying or division. Estimate the order of magnitude of the length in meters of each of the following. A ladybug. So a ladybug is really, really small, okay? But it says careful in meters. Is a ladybug 10 to the power of 0 meters? No. Is it 1 meter? No, it's not. Is it 0.1 meter? No, it's really small. Is it 0.01 meter? That's reasonable. So you'll say 10 to the power of minus 2 meter. Your leg, you could use this one, 10 to the power of 0 meters, which is equal to 1 meter. Your school building might be maximum 100 or let's say 50 meters high. So you can say 10 to the power of 2 meters. A giraffe is maybe 4 meters, 5 meters maximum. So this will be 10 to the power of 0 meters, okay? A city block, 10 to the power of 2. If an equation is dimensionally correct, does this mean that the equation is true? No, the numerical values must be correct. So if you plug in some values that you have, they should be also correct too. The radius of a circle is inscribed in a triangle, so you have a triangle like this, and you have a circle inside it. A, B, and C is given by the following equation, in which S is an abbreviation for A plus B plus C. Check this formula for dimensional consistency. So you have R, which is equal to square root of s minus a multiplied by s minus b multiplied by s minus c, divided all by c. R, A, and B are length, and S also is length. So you'll put, instead of all of these, length. Okay? So you'll say length multiplied by length divided by length. This one, all because they're the same, so they'll be 10 to the power of 3. Okay? This one cancels with this one, so you have 10 to the power of 2. 10 to the power of 2 remains inside a square root. Square root goes with this one, so you only have length left. So you also had length here because it's r, so length is equal to length. The equation is dimensionally consistent. The period of a simple pendulum, defined as the time necessary for one complete oscillation, is measured in time units and is given by the equation. Okay, you have this equation. Okay, now this is measured in what? Its length. This is the period. How to measure the period of a simple pendulum. Now, you have a square root, okay, which has length divided by gravitational acceleration or gravity. So you have meter, so you have square root, leave this pi, 2 pi. T is what? Is time. Let me solve this again so you can better understand. So you have time is equal to, I said leave the 2 pi. Length is what? So you have length. This is L. Gravitational acceleration unit, you have length, because it's what? It's meter second squared. Okay, so you'll see length divided by time squared. Okay, now length cancels with length and you only have time remaining. Okay, so this is like this. I'll show you. This is equal to 1 divided by time squared. Okay, then this one will be this one cancels with this one, you only have time remaining. Okay, so yes, the units are consistent. Now in a desperate attempt to come up with an equation to solve a problem during an examination, a student tries the following. Velocity is equal to, velocity in meter per second squared is equal to acceleration in meter per second squared multiplied by time in second. Now this is velocity. Okay, you'll see velocity squared is equal to acceleration multiplied by time. Okay, now look, acceleration is what? Is measured in meter per second. So you have meter per second squared, but this is squared too. So you have this one. So it will be meter squared second squared multiplied by, what's the unit for acceleration here? Meter per second squared. Okay, you have second here too. You can write it like this: meter per second squared is equal to meter per second squared multiplied by second. Second goes with second. You have the final result is meter squared divided by second squared is equal to meter per second squared. Are the units consistent? No, they are not. Okay, so the student is using a wrong equation, so he's going to get wrong results. Estimate the number of breaths taken by a person during 70 years. Okay, so he's 70 years. Okay, consider that he only that he takes one breath in 5 seconds. So you'll say 70 years multiplied by 365 days. 365 days multiplied by 24 hours. 24 hours is equal to 3,600 seconds. And then multiply by, divide all of it by 5 seconds. Okay. you can do something else. You can say 70 years multiplied by 365 days multiplied by 24 hours multiplied by 60 24 multiplied by 60 minutes multiplied by 60 seconds, and we said that in 5 seconds he only takes one breath, so divided by 5, and you will get the number of breaths he takes during his lifetime, which is 70 years. Estimate the number of times your heart beats in an average day. So let's say that your heart beats, actually it's more than that. Let's say that your heart beats once in a second, okay? So basically, you can say in an average day, so you have 24 hours multiplied by 60 minutes multiplied by 60 seconds. So you get what? I think 86,400 seconds. But this is what? You only change time. And your heart beats only once. So divide all of this by 1 and you still have 87,400 seconds. Okay, actually it's more than that, but we just assume that your heart beats once in each second. Estimate the magnitude of your age as measured in units of seconds. Let's say you are 16 years old. So you have 16 multiplied by 365 days multiplied by 24 hours multiplied by 60 minutes multiplied by 60 seconds. Try to find your age, okay? Or if you are 17, you can try 17. An automobile tire is rated to last for 100,000 kilometers. Estimate the number of revolutions the tire will make in its lifetime if its diameter is 0.3. So you have a tire, okay? And this tire is going to, what's it's going to, of course, oh come on, this is an I. So you have a tire, okay? The number of revolutions this tire makes in its lifetime, and it is rated, it's rated to 1,000 kilometers. Try to find the number of revolutions this tire makes if its diameter is equal to 0.3 meter, okay? So you'll say 1 revolution is equal to 2 pi r, okay? 1 rev is equal to 2 pi r. You'll study this in 12th grade too. You have radius. You have the diameter, which is 0.3. Okay, then directly add this here, 2 pi multiplied by 0.3. Okay, and you will get the result here divided by 100,000 kilometers. So you have 100,000 kilometers multiplied by 1,000 meter. Why do we change this to meter? Because you have the diameter in meters. So you'll say multiply by 1 rev divided by 2 times pi times 0.3. You'll get this result. Imagine that you are the equipment manager of a professional basketball team. One of your jobs is to keep a supply of baseball for games in your home ballpark. Balls are sometimes lost when players hit them into the stands as either home runs or foul balls. Estimate how many baseball you have to buy per season in order to make up for each losses. Assume your team plays 80 game home schedule in a season. So let's say that you lose 30 balls per game. So you'll say 81 times 30 balls you lose in a game. So you get this number, 2 times 10 to the power of 3 balls will be lost in a game. A chain of hamburger restaurant advertises that it has sold more than 50 billion hamburgers over the years. Estimate how many pounds of hamburger meat must have been used by the restaurant chain to make 50 billion hamburgers, and how many head of cattle were required to furnish the meat for these hamburgers. So let's say that mass of a cattle is equal to 400 kilogram, and mass for one burger is equal to 170 grams. Meal salt, let's say, you have here 50 billion hamburgers, so 50, you can write it like this, times 10 to the power of 9 burgers. You will say 50 times 10 to the power of 9 hamburgers multiplied by the meat for one burger, which is 170 gram. This is just an assumption, guys. Then multiply by one head, which is then divided by 400 kilogram. Multiply all of this by 10 to the power of minus 3 kilogram, and you'll have this. Gram goes with gram, and then kilogram goes with kilogram, and hamburgers goes with hamburger. You only have head, which means the cattle, okay? So you have 2.1 times 10 to the power of 7 cattle, okay? This is the amount of cattle, the number of cattle that will be used in this restaurant over the years. Now estimate the number of table tennis balls that would fit without being crushed into a room that is 4 meters long, 4 meters wide, and 3 meters high. So careful, length and width are the same. So the number of balls fitting the length and the width of the room, you have 4 meters, okay, and you have, careful, the diameter of the room is 3.8, sorry, the diameter of a ball, not the room, is 3.8 centimeters. Change this to meter, okay, you have 0.38 meters. You'll say 4 divided by 0.038 meters. This is for the width, and it's also for the height too, for the length too. So length and width, they have the same length, they have the same value, so they will be the same too. The number of the balls fitting in the height, so you have 3 divided by 0.038, you have 79 balls, you have 105 balls. Then 105 balls, this is for the length, and this one is also for what? For width. And the last one, 79, is for the height. So multiply all of this and you get 88.7 times 10 to the power of 5 balls. Calculate the circumference and area for the following circles use the following formulas. You have for the circumference 2 pi r circumference, and for area pi r squared, okay? Circumference will be what? Let's just use c, which is equal to 2 pi r. Okay, then you have what? 3 point, so you'll see. So make this one 0.035 meters, and this one will be 0.0465 meters. Okay, so you have 2 times pi times 0.035 meters. Try to find this. This is for the circumference for the first one. For area, you will say area is equal to pi r squared. So you will say pi multiplied by r, which is 0.35 squared. Okay. For b, it's the same thing. Okay. How long does it take to count an amount of 5 billion dinners of 5 dinner notes, knowing that counting one takes 1 second? So you have 5 times 10 to the power of 9 notes. Divide all of this by 500 notes because you are counting 500 notes. Let's say you can count only one in 1 second. Because it needs in second, and you have 10 hours daily. Sleeping and eating requires 10 hours daily, so you'll be subtracting this. So you have 24 hours minus 10, so you have 14 hours left. So you'll be counting 14 hours. Multiply by 1 hour divided by 3,600 seconds. Multiply by 1 day divided by 14 hours. So second goes with seconds, hour goes with hour, and notes goes with notes. So you have 198 days. Okay. So you need 198 days to count 5 billion dinars of 500 dinar note. Exactly one portion of ice cream is to be made in the form of cube. What should be the length of one side in meters for the container to have the appropriate volume? Use the following conversion. 4 portions is equal to 3.786 times 10 to the power of minus 3 meter cubed. Volume of 4 portions is equal to this. If you want to find the volume of one portion divided by 4, okay, because it's 4 portions, then this is a volume of one portion, and volume is equal to length multiplied by length multiplied by length. You can also say length times height times width, but it's also true because this is meter, and this is meter, okay? So you can say volume is equal to length cubed, okay? And then take the cubic root for both. So you take the cubic root for this one and for this one too. Cubic root, this one goes with this one, so you have length, which is equal to cubic root of volume, okay? Then you have found volume of each of one portion. Put it here and find the result, which is 9.818 times 10 to the power of minus 2 meters. You can obtain a rough estimate of the size of a molecule with the following simple experiment. Let a drop of oil spread out on a fairly large but smooth water surface. The resulting oil slick that forms on the surface of the water will approximately be 1 molecule thick. Given an oil droplet with a mass of 9 times 10 to the power of minus 7 kilogram and density of 918 kilogram per meter cube, that spreads out to form a circle with a radius of 41.8 centimeter on the water surface. What is the approximate diameter of an oil molecule? So you have mass, you have density, okay? So the formula for density is like this. Density is equal to mass divided by volume. Now you have mass and you have density. You need to find what? You need to find volume. So volume will be mass divided by density. Okay, as you can see here, to find volume, you'll say mass divided by density, and you get this result. And you will use this to find the diameter. So diameter is equal to volume of area. You have the radius, which is equal to 41.8 centimeters. So volume, which you found here, put it here, and then you have area. Area is equal to pi r squared, which you studied above. Then you have 0.418 squared. Calculate and you'll get this one. I think this is it for today. If you need all of these questions solved, just send me an email and I will send you all the solutions, okay? Most of the questions here are not related to chapter 1, and some of them are unrelated to the topic that you have been studying since now, okay? But if you want to get the full solution of all of these, just send me an email and I'll send you the PDF. This is it for this video, and